Hello guys, today we're gonna start lecture 4 assembly language, and I think I've covered this with most of you. If it's John, Rayana, you were in the C++, I didn't cover it with you, but the other guys, mostly the foundation guys, I covered it. And here's the offer, guys. Remember I told you about the tournament? And sorry I had to announce it here. I don't have emails, but leave me comments under this video. We're gonna make the tournament. This is what I'm gonna do. We're gonna finish the assembly. I'm gonna do one tournament in the assembly, a programming contest, let's say. I'm gonna offer $100 for the first place. And we're gonna do another one on the advanced C++. I'm gonna give you the advance before the fall, so you will all know it. But I need at least 10 in each group, and I don't know if you want guys, if you want the YouTubers to join us. I'll leave that to my students to decide. Please let me know if you want them to participate, but it's gonna be under one condition. They have to be college students. They have to prove that they're, let's say, at least under 25. Maybe we're gonna put an age, we're gonna set an age or something, but prove to me that you are in a college or studying, or that you're not a professional programmer and you can participate. What we'll do, we'll give an exam at the end of this assembly language. When we finish those, hopefully I'll start the advance before the end of this, so then we start I'll give you the assembly exam, and it's gonna be covering the material and mostly programming. The advanced, the same thing. I'm gonna offer also the security class. I'm gonna show some security stuff here. I'm gonna also, and this is for my son, I did it for my son Faisal. I'm gonna give math for first graders. I went and I studied the Singaporean system, how they teach it, and Korea and Japan, because those were ranked as the 3 highest in the world. And I went and I studied the system, and I'm gonna put a video for first grade, second grade, third grade, hopefully. So if you have a brother, a nephew, anything, please let them know. Please let the other students know about the tournament or contest. We'll make it, let's say, after a week after we finish the assembly class. Most lectures are gonna be 20-25 minutes. I think that's good. Please, if you have any concerns, if any suggestions, please leave it in the comment section. Thank you guys. So this is the 4th lecture. Why is it saying 3? Okay, it's supposed to be 3. We're gonna take here what? It's lecture 4, guys. The hexadecimal number system. We took the binary, base 2, 0 and 1. We took the decimal, which is our numbers, 0 to 9, base 10, and we took the octal, which is base 8, 0 to 7. I don't know how's the microphone going. Hexadecimal, we're gonna convert from hexadecimal to the other bases, binary, octal, and decimal, and vice versa. We're gonna show all this. Now, what's a hexadecimal number? Is base 16. We know base 2, base 10, base 8, and base 16. So the range of my numbers is what? From 0 to 15. 0 to 15. And remember, I can't put 10 and 11 and 12 and 13 and 14 and 15, because those are 2 digits. Those are considered 2 digits. How am I going to distinguish them from a 2-digit number or a 1-digit number? So what they did is they said 10 equals A, they used letters, 11 equals B, 12 equals C, D, E, and F. So is this a hexadecimal number? 9 is a valid hexadecimal number. A also valid. 8 valid. F valid. 9 is valid. 8 is it valid? No, remember, A, B, C, D, E, F. So this is not valid because of the H. Not hexadecimal because of the H. Base 16, meaning 2 to the power 4. So we group into 4s. So if I have this binary number, I group into 4s. So I'm going to take, starting from the right, and then I'll take those 4. And then I'll take those 4. And I'll take those 4, and this came exactly 16 bits. I think so, it's right. So first 4 binary numbers. If you remember in the octal in lecture 3, what did we take? Octal was 3 digits. Why was it 3 digits? 2 to the power 3, which is 8. Base 8. Base 16 to the power 4. And we had 1, 2, and 4 for the octal, representing the first 3 bits. Here I have 1, 2, 4, and 8. If we count those, what's that? 1, 1, 1, 1, 1, 1 is 15. All of them are 1s, is 15, representing the F. Representing the F. Now if I take those 4, what is it going to be? 1, 2, 4, and 8. And what do I have? I only have the 4, so this equals 4. If I took this 1, I usually put them on top of it. 1, 4, 8, and this is what? 2 and 8 is 10. 10 is what? A. 10 is A. And always try to put them 10A, B 11, C 12, D 13, E 14, F 15. So what's this? 1, 2, 4, 8, which is gonna be what? This is 8 plus 1, which is 9. This is gonna be 9. And why did we say 1, 2, 4, and 8? What does that represent? That represents 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3, which is 8. 8, 4, 1, 2, 1. Now converting base 2 to base 16. Consider each group as a single binary number after grouping into 4s. We did that. This gave us, this is what it's representing. So this one is 1 to the power 2 to the power 1. This is 1 multiplied by 2 to the power 2. And this is 1 multiplied by 2 to the power 3, which equals 1 plus 2 plus 4 plus 8. 15 equals F. Never put 15, that's considered wrong. This is 8. If I had 0, 0, 0, what's that? That's going to be 0. 1, 2, 3, 4. 1, 1, 1, F. And here's this. And this, by time, you'll get used to it. 10, 10 equals 10, which is A. 10, 10 equals 10. That's the way I get it. So, and that's 9. And this binary number is what? Is this hexa number. Now there's another example. Let's do it real quick. We group into 4s, yeah? So I did a dash between them. I didn't want to leave a whole space. So what's this? 1, 2, 4, and 8. What's this gonna equal? 11. 1, 2. I don't need to continue with the zeros, so this is 0. 11. What did we say? 11. A good thing, always write your numbers on the side so you don't forget them. I always do it, and the students always do a mistake, and you're gonna see you're gonna do a mistake. A equals B equals A equals 10, B equals 11, C equals 12. Oh, it's not writing here. C, D, and E and F. So what's this two? What's this? I've got 1, 2, 4, and 8. 8 and 4 is what? 12. 0, 0. 12, it's C. So this is C, this is B. What's this? 1, 2, 4, and 8, and this equals 5. What's this? 1, 2, 4, and 8, 4 and 8, 12, and 1, 13. 13 is what? D. And this is what? 2. And this is E. Why E? Because I know it's missing a 1, and I know total is 15. So put 1, 2, 4, and 8. So 8 and 4 is 12, and 2 is 14, which is E. Sorry about my handwriting. This pen is, you know what, I got a pen from my phone. It might work. I'm gonna check it. I've got a pen from my phone. It might work on the screen. I have a touch screen. I'm gonna try and see if it works. 11, 2, 8 and 4, 12, which is C. 5, you see, wow. The 4 and 1. Why did I put 3 here? This should be 5, guys. And what's that? 13. Was it 13? Now I'm gonna check it. 8 and 4 and 1, 12, 13. This 2 and this is E. So this is what we got. Did I put a 10 on that one? The previous one, did I get 10, 10? When I did it with handwriting. Sorry guys. "13" is D. I don't know why I had it as A. Sorry guys. So this binary number equals this hexa, and how do I indicate this hexa? I put that 16. Converting base 16 to base 2. What do I have? 9D A7, and where is the 9D A7, and each hexadecimal number is what? How many bits? Remember, from the base 16 to the power 4, so I group into 4, so each hexadecimal number is 4 digits, meaning the 7 I'm gonna have, well, for the 7 I'm gonna have 1, 2, 4, and 8, and for the A I'm gonna have 1, 2, 4, 8, and for the D I'm gonna have the same thing, 1, 2, 4, 8. What's the 7? It's gonna be 1, 3, 7, 1, 1, 1, and 0. What's the A? A, remember we said 10, value of 10. 8 and 2, 10, 10. Here's the A. What about the D? D, we said A, B, C, D. So 10, 11, 12, 13. D is 13. How do I represent 13? 8, 4, 12, 0. I'm not gonna take the 2. It makes it 14. I'll take the 1. and 9 equals what? 8 and 1. So we combine all those numbers and we get our number. Here we grouped each number represents 4 numbers. And I go back on it so you can see it closely. The 7 4 bits equals 0 1 1. The A equals 10. 10, how can I represent it in binary? 1 0 1 0. D is 13, how can I represent it in binary? It's going to be 1 1 0 1. 9 is 1 0 0 1. Now converting base 8, which is what? Octal to I don't think I modified the slide. This should be base 16. So what do? We convert to binary, and then from binary we convert back to hexadecimal. That's the easiest. For example, if I gave you let's see, this octal number 753. Each octal number is what? 2 to the power 3, 3 binary digits, 1 2 and 4, and this is 3 1 1 0. That's 3. What's the 5? Using the 4 to 1, it's going to be 1. What's the 7? It's going to be 1 1 1. So I'll take this this is what? This octal number 753 in binary. And what do we need to do? We need to convert it to hexadecimal or base 16. So this is binary. I need to get base 16. 16 we group into 4s. So I have those 4s. So I'll have 1 0 1 1, and I'll have 0 1 1 1, and I'll have 1 by itself, and I can add 3 zeros on the left of it. That won't change the number. So this is 1. This is what? 8 and 4 12 and 2 14, which is E. And what's this? 8 and 2 10 and 1 11. So that will be what? B. So my number, this octal number in hexa is what? 1EB. 1EB, we say base 16. Now convert that's from octal to, and vice versa, we do the same. From hexa to octal, we do the same thing. Convert it to binary. Each hexadecimal digits is 4 digits. It's 4 bits, and then group into 3s. And here converting from hexadecimal as same thing. What do? Convert to binary, and then from binary convert to the base you want. So binary here is our major thing. See, we go into binary between every when I convert between bases. We can do it by the long division and taking the remainder if we don't want to involve the binary, but I think that one is much easier. So let's take a hexadecimal number. Let's say I have a C1, and that's in hexadecimal base 16. So the 1 is 4 digits and the C is 4 digits. 1 will be 1 0 0 0. That's using what? 1 2 4 8. So that's for that and that's for that. The C, and those are parentheses, don't think they're C1. C is what? C is 12. ABC is 12. C has a value of 12. How can I represent a 12 in 1 2 4 8? It's gonna be 1 1 0 0. So now I have this whole number in binary that I need to convert to decimal. So I'll say 1 1 0 0 0 0 0 1, and you know we can do what? The position notation 2 4 8 16 32 64. I didn't put them because they're zeros, we're not gonna take it. And here 128. So I'm gonna add the 128 and 64. It's gonna give me 32 and 192 and 1. So this is 193 in what? In decimal. I converted from hexadecimal, which is C1, to binary, and from binary to decimal base 10, which is 193. So let's take an example, or we can use the mod base 16. Remember we said the long division. Let's take this big number, and this is in decimal. I should have put this in decimal, because this can be an octal, this can be a hexa, but it can be a binary. But we have to indicate that's a decimal number. So we do the long division. How do we do the long division? We have the 3215, and I divide it by 16, my base, my numbering system that we are using. Don't think this is hard. Look at it. What do you think? 32 what is it gonna be, 2 or 20? It's gonna be 20. That will give me what? 3. That will give me 320. 3200, which is 3200. If I put 20 here, what's the remainder? It's 15. And now what? Divide again by 16. 20 divided by 16 is 1. What's the remainder? 4. And I have 0 and 1. And we read this way. Ooh, sorry. So we'll have 1, 4. Should I put 15? Hexadecimal? Oh, no, that's wrong. Well, what should it be? 15 is F. So I'll have what? 1, 4 F. How is it 400? Let's use the calculator. That's 400. I don't think it's 400. Yeah. So it should be 20. So that was a mistake. Control Alt Shift and F5 I think will take us to the same screen. No, come on. What did I do? Okay. I don't know how that happened. That's the first time, but anyway. What was for the slides? I didn't want to go all over the slides. it was shift alt. So this is wrong, guys. Sorry. Try 6415. Should give me this, but this will give me F4 and 1, and we read that way. So this is not wrong, this is wrong also. Should be, if it was what? Think of it as 6415. Sorry about that mistake. If you have any questions, guys, please let me know in the comment section below. What we're gonna cover next lectures is the addition and subtraction for those numbering systems. Remember, those are really important. After that, hopefully we'll go into the gates. I think that's gonna take 3 lectures. We're gonna take a lecture for representing characters. Remember, characters and negative numbers. And we're gonna take maybe 2-3 lectures on Boolean expression and Boolean algebra, and if you remember, gates. And then we'll go to chapter 2, which is really important. Remember, guys, and don't forget the tournament. Please let other students know. $100 for the assembly I'm offering, and $100 for the advanced C++. And here's a better deal: if you get first in both of them, you get $250. I don't know, I have a feeling one of you can do it. I don't know if he knows himself. Hopefully he does. Thank you, guys, and see you next class. Boo boo.